Determine the formula for each given sequence. To do this, we'll analyze the sequence, hopefully notice a pattern, then write a possible formula, and then check to see if the formula actually works. Number 1, we have 1, negative 3, negative 7, negative 11, negative 15. Analyzing the terms of the sequence, notice they're decreasing by 4 each time. 1 minus 4 equals negative 3. Negative 3 minus 4 is negative 7. Negative 7 minus 4 is negative 11. Negative 11 minus 15 is negative 4, and so on. Instead of writing minus 4, we can also write plus negative 4. Recall repeated addition can be expressed using multiplication. And therefore we might be thinking a possible formula might be a sub n equals the first term of 1 plus multiple negative 4s, or plus negative 4 times n. But right away we should recognize this won't work. Notice for a sub 1, or when n is 1, we know we want to add 0 negative 4s to 1, but as is, we have 1 plus negative 4 times 1, or we're adding 1 negative 4 to 1, which equals negative 3, which is the second term, not the first term. So we're adding a negative 4 one time, but we know we want to add negative 4 0 times for the first term. But we can easily modify the formula. Instead of adding n multiples of negative 4, we can add n minus 1 multiples of negative 4. Let's check to make sure this actually works. Now we have a sub 1 equals 1 plus negative 4 times the quantity 1 minus 1, or 0, which does give us the first term of 1. Let's try a sub 2. To obtain the second term of the sequence, we want to add 1 negative 4 to positive 1, or subtract 4 once. Using our formula, a sub 2 equals 1 plus negative 4 times the quantity 2 minus 1, which is 1, which does give us negative 3, the second term. So now that we have the correct formula, let's talk about different ways to express the formula. One way is to leave the formula in its current form and leave it as a sub n equals 1 plus negative 4 times the quantity n minus 1. We also know adding a negative is equivalent to subtracting a positive, and therefore we can also express the formula as a sub n equals 1 minus 4 times the quantity n minus 1. Or for another option, we could clear the parentheses by distributing and then combine the like terms. Distributing in this form or the form above, we have a sub n equals 1 plus negative 4 times n, or minus 4n, and then plus negative 4 times negative 1, which gives us plus positive 4. Simplifying, we have a sub n equals 5 minus 4n. This would be another way we can express the formula for the sequence, all of which would be correct. Looking at number 2, whenever we have a sequence of fractions, it's often helpful to analyze the numerators and denominators separately. This one's actually much more straightforward. Notice all the numerators are 2, and then looking at the denominators, we have 3, 9, 27, 81, which are all powers of 3. 3 is 3 to the first, 9 is 3 squared, 27 is 3 cubed, and 81 is 3 to the fourth, and so on. Which indicates the formula for a sub n, which indicates the formula for the sequence a sub n is equal to 2 divided by 3 to the power of n. Sometimes we have to manipulate the exponent to, let's say, n plus 1. So let's go ahead and check to make sure this actually works. For a sub 1, we have 2 divided by 3 to the first. For a sub 2, we have 2 divided by 3 squared. And we can see in both cases, we are getting the correct fractions for the sequence. The correct formula is a sub n equals 2 divided by 3 to the power of n. And then finally for number 3, we have a different type of sequence. Notice the terms of alternating sign. We have a negative, a positive, a negative, a positive, a negative, and so on. Whenever we have an alternating sequence, it's often helpful to first consider the related non-alternating sequence. So let's begin by considering 6, 11, 16, 21, 26, and so on. If we can find the formula for this sequence, we can modify the formula so that we get the given sequence, which will involve raising -1 to a power of n, or n plus 1. But let's first focus on the non-alternating sequence. Notice in this case the terms are increasing by 5. 6 plus 5 is 11. 11 plus 5 is 16. 16 plus 5 is 21. And 21 plus 5 is 26. Using what we learned in number 1, we know that a sub n equals 6 plus 5n is not going to work because the first term is 6, and a sub 1 is going to be 6 plus 1 factor of 5. So we don't multiply by n, we multiply by n minus 1. Let's check it. A sub 1 equals 6 plus 5 times 1 minus 1, or 0, which is 6. A sub 2 is equal to 6 plus 5 times the quantity 2 minus 1, or 1, which does equal 11, and so on. So we have the correct formula for the non-alternating sequence. But let's go ahead and simplify it. Let's clear the parentheses and combine like terms. We have a sub n equals 6 plus 5n minus 5. Simplifying, we have a sub n equals 6 minus 5 is 1, giving us 1 plus 5n. So this formula gives us the sequence 6, 11, 16, 21, and 26, and so on. To make the terms alternate sign, what we can do is multiply this formula by -1 to the power of n, or the power of n plus 1, depending on how the signs alternate. So let's first try a sub n equals -1 to the power of n times the quantity 1 plus 5n. We know we get the correct numbers, we just want to make sure we get the correct sign. For a sub 1, we have -1 to the power of 1 times the quantity 1 plus 5 times 1. -1 to the first is -1. Inside the parentheses we have 1 plus 5, which is 6, which does give us -6. Let's try one more. A sub 2 is equal to -1 squared times the quantity 1 plus 5 times 2. The square of -1 is +1. +1 times 11 is equal to +11. We are getting the correct terms as well as the correct sign, which indicates this is the correct formula for the sequence. I hope you found this helpful.